Welcome everyone, my name is Caroline and I will be talking to you about cost-efficient multi-cluster monitoring with Prometheus, Grafana and Linkerd. So I'm a senior DevOps engineer at BWI, which is the IT services provider for the German Federal Ministry of Defense. And at BWI, my work centers around building a secure private cloud for the German armed forces. Before that, I worked at Philipp Connect for 5 years. I started there as a software engineer, and later on I joined the cloud platform team. And yeah, apart from my day job, I'm working towards my master's degree in computer science at Georgia Institute of Technology. So today, however, I will talk to you about my previous job at Philipp Connect, and to be a little more specific, I'll tell you about how we found our path to finding a monitoring solution that fit our needs and how we used Linkerd to make it work. So a little bit more context about Philipp Connect. Philipp Connect is a European financial services provider with offices in Germany, Spain, and Italy, offering connectivity to over 3,000 financial institutions and banks in 11 countries. So Philipp Connect's main product is an open banking platform, which serves as a basis for account aggregation, payment initiation, categorization, and account and portfolio switching solutions. And what's also important to say in this context is that Philipp Connect is a regulated payment institution, so security and compliance is a really big topic, and it has to be considered at every step of the way. Right, now, before we talk about solutions, let me first explain the actual requirements we had for our cloud monitoring setup. So basically, we needed some kind of system to collect application and infrastructure metrics, so we could use those metrics for alerting and also to help debugging and to manage incidents. And that solution should also guarantee secure data transfer and ideally not cost a large amount of money, so it should be rather budget friendly. And based on those points, we already figured out that we didn't need any type of long-term storage for the metrics. I know that there are a lot of solutions out there using object storage and some systems like Thanos, if you might have heard of it. But yeah, in our case, it just wasn't necessary because we had a rather short retention time of 2 days. And this is what our initial solution looked like. At that point, we only had a single production cluster and another cluster for development. So we had a single central Prometheus deployment that scraped metrics from infrastructure services and the production services. And then we had a central Grafana that used this Prometheus as a data source. So it's nothing special. You've probably seen it a lot along your way. But then, as time passed, Philipp Connect's business requirements started to change. So previously, we only had 2 bare metal Kubernetes clusters on which we hosted all production environments. But now we had to deploy the whole open banking stack to AWS in the Bahrain region, so in the Middle East. And then we also had to migrate some production environments to Google Cloud in Germany and Spain. And on top of that, we had to manage 2 Kubernetes clusters in private clouds on OpenStack and VMware Tanzu. So now, among many other things, we needed to kind of rethink how we provide observability over like a not so small amount of clusters anymore. And this is what our first, let's say, naive solution looked like. We basically just replicated the whole stack among all the clusters? Well, the good thing was we could just copy and paste everything. It was easy to deploy, but yeah, it got more and more confusing with all the different endpoints, and it needed a bunch of resources. So yeah, overall, it just wasn't a good and sustainable solution. We then figured out that it makes sense to centralize certain services that are needed among all the clusters. And in that regard, it was our first intuition to use a central Prometheus to federate all other Prometheus instances. So federation means that one Prometheus is configured to scrape metrics from another Prometheus instead of the metric source directly. But yeah, you might already notice it can get ugly pretty quickly. So first you have to decide beforehand what kind of metrics you actually need for your dashboards. And then you have to meld that into a filter in your federation config. Because if you don't do proper filtering, there's a really high risk of just completely overwhelming that central Prometheus. So yeah, it just won't be able to handle all that incoming data at once. And then, yeah, you have the traffic overhead if you constantly ship metrics from one place to another. And yeah, disk space can also be an issue if you have to store everything twice. So after going back and forth a little, this is the solution we decided to go with. So we would drop the central Prometheus and instead use the other Prometheus instances as data sources for a central Grafana. So this way you don't need to pre-select metrics and you don't need to maintain this complex federation config. And what's really good, you just pay for the traffic that comes from the queries within your Grafana dashboards. So if your Grafana usage pattern looks somewhat similar to ours and you look at dashboards every once in a while and you don't run all kinds of crazy queries every day, it's just significantly less expensive. And if you add a new cluster, you can just plug it in as a new data source for the Grafana. And yeah, what's also great, you save disk space. Now, yeah, you're probably right if you think that this kind of topology leads to the central services being the single point of failure. So what we did is we used a regional GCP cluster for the central cluster. So we replicated it over multiple availability zones, and the control plane was also replicated. So we tried to make it as stable as possible. All right. Now, how do we make this happen? So in theory, we would expose every single Prometheus to the internet and create a bunch of DNS entries. And then, because we need secure data transfer, we would generate and distribute certificates everywhere. And yeah, so we only have MTLS. Now, even if you're using something like Cert Manager, it sounds like a lot of work, right? And also managing all those DNS entries, it can be tedious. And yeah, we know that naming is one of the hardest problems in computer science. You probably know that. So we started looking into ways to automate this whole process. And we then realized that with Linkerd, we basically already had a solution at hand. So Linkerd. We've already been using it in production for a couple of years, and yeah, it's done a great job for us. Especially the automatic MTLS has been really helpful, and yeah, it saved us from a lot of pain. And the good thing is you can also use it for inter-cluster communication. So Linkerd supports cross-cluster communication with multi-cluster extension, which is deployed separately from the control plane. And just like the in-cluster deployment, it gives a unified trust domain, which can be validated at every step of the way. It's designed to be failure resilient, so you won't lose the whole cluster connectivity if you just lose one. And also it supports basically all types of networks, whether it's like VPCs with a certain cloud provider or some kind of cross data center connectivity. So yeah, overall you get the same functionality for cross-cluster communication as you get with Linkerd within a cluster. And now this is what it would look like in our monitoring use case. Now we have two clusters here. The left one is a workload cluster and the other one is the central services cluster. And the two clusters are linked so that the central cluster acts as a source and the workload cluster acts as a target. Now, in the workload cluster, we have a Prometheus instance, and in the central cluster, we have the Grafana. And both of them are meshed through Linkerd. So we have the proxies running left and right as sidecars. Now, in the central cluster, we have a service mirror running, which is actually one part of the multi-cluster control plane. And the service mirror watches for services in the target cluster with the mirror Linkerd IO exported true label. And it replicates those services into the source cluster so that the Grafana in the target cluster can use this replication for service discovery, and calls to the Prometheus in the source are routed through the multi-cluster gateway, which is another part of the multi-cluster control plane. And this is basically what this whole setup actually feels like. It's pretty simple. You basically don't even need a diagram for that, but yeah. From the Grafana point of view, you can just treat the mirrored Prometheus service exactly like any other service in the same cluster. So you have cluster internal DNS name, which is automatically assigned by the service mirror, and you don't need to worry about certificates at all because the whole mutual TLS stuff is handled through Linkerd. So I already mentioned earlier, the Prometheus instances are connected to the central Grafana as data sources. And yeah, that's what the data source configuration for the Grafana would look like. So for the Prometheus URL, you can just use the cluster internal DNS name and the Prometheus port. And yeah, the protocol has to be HTTP because yeah, Linkerd handles all the MTLS stuff. And yeah, this is an example of a Grafana dashboard, what it would look like. So on the left-hand side, you have a drop-down menu where you can select all the available data sources, and you could just choose the Prometheus of which you can see metrics from the source cluster. So yeah, let's talk about how we deployed the whole multi-cluster setup. When we looked at our existing Linkerd installations, we realized that we needed to do one more thing before we could start deploying the multi-cluster stuff, and that is we needed a shared trust anchor. So the trust anchor is the root certificate for, that signs the identity certificate, which in turn signs all the data plane proxy TLS certs. So in the end, the identity issuer acts as a CA for one cluster, while the trust anchor is a shared CA over all the connected clusters. Well, in our previous setup, we hadn't connected our clusters before, and that's why we had separate trust anchors for the Linkerd deployments. But yeah, before we rolled out the multi-cluster stuff, we had to exchange the trust anchors for a shared one to be able to proceed. So how do you do this? First of all, it's not as scary as it sounds like. I know that certificate rotation can be scary. Some of you might have been there. And the good news now is that you can do it without a downtime by just bundling the old and the new trust anchor. So there are some really helpful resources in the Linkerd docs on manual trust anchor rotation. And what we did is we just went through all the steps a couple of times with a few test clusters we set up specifically for that. And then we created our own runbook. And in the end, we just went through it step by step, and it just worked really well. All right, now that we have a shared CA, we can proceed with the control plane deployment. And there are basically two options on how to do that. So the first one is to use the Linkerd CLI tool using the Linkerd multi-cluster install command, which you can see here, together with kube control. And it installs the multi-cluster control plane, and it includes the gateway, and a few other things such as RBAC and custom resource definitions for cluster links. Now, in my back then team at Film Connect, we pretty much deployed everything in a GitOps way, so it was really important for us to keep it that way. And we were running deployments with Argo CD or with GitLab pipelines, and we basically used Helm charts for everything. So that's what we also wanted to do for the multi-cluster components. So luckily, there's a Helm chart for that in the official Linkerd Helm registry. It's called Linkerd Multicluster, and it's pretty easy to use. And a really good advantage is that you can configure way more things than if you just use the CLI command. So that's also why the Helm chart is the recommended way for production usage. For example, if you already know that you only have unidirectional traffic from source to target, you can just disable the gateway, and that way you can save a load balancer IP. So just think about it. Right. The next step after the control plane deployment is to actually link the clusters. And of course, there's a Linkerd CLI command to do this, which creates the link custom resources and a few other things to make the cross cluster connection work. And one of the crucial parts here is that you have to run the link command in the target cluster to get the target cluster credentials, which is a kube config. So the kube config of the target cluster has to be persisted in a secret in the source cluster. Now, how did we deploy the cluster links? Just like the control plane, we wanted to stick to GitOps and deploy everything in the form of Helm charts. The only little hurdle now was that there's no official Helm chart to deploy all the resources that are generated by the multi-cluster link command. So what we did is we just ran the command in one of the clusters, and we baked the output into our own Helm chart that we deployed in the central services cluster. And the chart that we created, it provides a list of cluster links where you can configure the external gateway IPs of the target clusters, and a few other things. And the kube configs for the targets actually are not part of the chart. They have to be provided through existing secrets. So you can either manually create the secrets before you roll out the Helm chart, or you can use some kind of external secret management tool, depending on how you manage your secrets in your clusters. But anyway, you won't get around running the multi-cluster link command at least once to get those kube configs and to somehow save them somewhere. If you want to look at an example of this Helm chart, you can scan this code, and it's a link to a Helm chart, my personal GitHub account. All right, we're reaching the end of the session, so let's wrap things up. If you're dealing with a multi-cluster or even a multi-cloud environment, it makes sense to keep your metrics local, but to centralize access to your metrics. It can be significantly more cost efficient, it's more scalable if you add new clusters, and it will definitely save you some nerves. And especially if you're already using Linkerd as a service mesh, or if you're thinking about using it, you should look at the multi-cluster extension, because it makes cross-cluster communication just as easy as Linkerd within the cluster. And the last point, it's possible to deploy multi-cluster components in a GitOps way, using Helm charts for the most part. You just need to somehow get the target cluster credentials once, and after that, it's just like any other declarative deployment. All right, that's it from my part. Thanks. I will be joining the roundtable discussion at 12:30 if you want to talk a little bit more about that, about multi-cluster, Linkerd multi-cluster, or yeah, using GitOps for Linkerd, any kind of topics. Just join me there, and thank you.
Thank you. We have a couple minutes for questions, if anybody has any. Two at once. Great. Hang on a second. I'm going to do this one first, and then you.
Hi. I have a question. What was the hardest part when you need to set up in production multi-cluster environment? What was the hardest part setting on production environment in multi-cluster?
It was kind of quiet. I'm sorry.
The question was, what was the most difficult part about actually setting up the multi-cluster extension in production in your environment?
The hardest part, I mean, the scariest part was obviously the trust anchor rotation. But yeah, we tried that a couple of times, and after that it was just deploying a couple of Helm charts, and it's just like rolling out any other service. Like, yeah.
Okay, hi there. So basically I do have two questions. The first one is, if you link the clusters, does it provide some kind of a tunnel that you're able to do a two-way communication between services in the clusters? So that's the first part. And the second part is there is a possibility if I do the Linkerd tunnel to access the main Kubernetes control panel on the other clusters, because like the case would be, for example, to do the Argo CD multi-cluster configuration and to like tunnel it through the Linkerd, for example. Thank you.
Well, I mean, yeah, two-way communication is possible. So if you export services from one cluster to another, you just have to add this label to a service, so it gets replicated to the other cluster. And if you want to do the same the other way around, you kind of have to do the same. You just have to have two gateways in both clusters. Yeah, and then you have the MTLS tunnel for secure communication. And the other question, the second was?
The second one seems to be whether you could use multi-cluster to tunnel the kube API itself.
I think you could do that if you just mirror the service. I mean, it's you can mirror like any kind of service.
I think that's an excellent question to bring up at the roundtable, actually, where we can also double check with a couple other folks.
Okay.
All right. Thank you very much. Much appreciated.
Thank you.